Right now, as you are reading these lines, two letters are drifting through space toward Earth that almost no one is paying attention to. They were sent from two opposite sides of a boundary that no civilization has ever touched before. They were written by two machines the size of a small car, traveling through two different regions of space that no human has ever seen. These are not new probes. These are not products of modern engineering. They were assembled in the same workshop in California nearly 50 years ago, before personal computers existed, before most of the scientists now reading their data were even born. The memory on each spacecraft is less than the memory in your car key. The transmitter on each spacecraft has the power of only a refrigerator light bulb, and those two ancient twin machines, right now, are sending back to us something no scientific model ever predicted: two letters telling two completely different stories about the same boundary. One spacecraft says the boundary is chaotic and blurred, the other says it is sharp as a knife edge. One spacecraft measured plasma density rising 80 times as it crossed, the other measured only 20 times. One spacecraft says streams of material from outside have slipped in and penetrated the solar system. The other says there is nothing at all. The researchers analyzing that data are not using words like interesting or surprising. They are using words like puzzled, contradictory, and we have misunderstood the shape of our own home. This is the story of Voyager 1 and Voyager 2, and this is the part the headlines do not tell you. It is not only that the two brothers sent back two different answers to the same question. It is that the final answer to that difference is changing the way we understand Earth's place in the galaxy. That is what is happening right now that no one is talking about. And the most fascinating part is, after years of analysis, scientists have finally understood why those two letters were so different. The answer is not that one of the two spacecraft was wrong. Stay with me, because by the time this story ends, you will never look at the night sky the same way again. Subscribe right now if you want to hear more stories like this, because we are only just beginning. Two machines the size of a small car are drifting in the darkness farther from Earth than any object humans have ever sent into space. Voyager 1 is flying north of the galaxy about 24 billion kilometers from us. Voyager 2 is flying south about 21 billion kilometers away. They have been out there nearly 50 years. There is no fuel to turn around. No other spacecraft is on the way to meet them, and both are slowly dying. But right now, they are still transmitting signals back to Earth. Here is a way to picture that distance. A radio signal from Voyager 1 takes about 23 hours to reach our antennas. From Voyager 2, about 20 hours. That means when you read the data Voyager sends back today, you are reading something that left the spacecraft nearly a day earlier. Both brothers are flying away from each other and from us at more than 600,000 kilometers per hour. The distance between them can only increase forever. And here is something very few people know. On this entire planet, there is only one antenna left that can still send commands to Voyager 2, a 70-meter dish located in Canberra, Australia. If that dish fails, we lose the ability to talk to Voyager 2 forever. The transmitter on each Voyager machine has a power of only 22 watts. The little light bulb inside your refrigerator uses more electricity than that. And when that signal travels across 23 light hours and finally reaches an antenna on Earth, its strength has dropped to weaker than starlight. The data rate now is only 160 bits per second, slower than a dial-up modem from the 90s. Humanity has the most powerful technology in history yet. To speak with its two farthest representatives, we depend on a single dish in the southern hemisphere and a signal weaker than starlight. And what makes the two brothers special is not that they are still working after nearly 50 years. What is special is that when they stepped across the final boundary of the solar system, they sent back two completely different letters. If only one spacecraft had crossed, we would never have known. If both had sent back the same answer, we also would never have known. The difference between those two letters is the answer itself. And to understand why that difference matters so much, we first need to know what the scientists expected. Before we talk about what the two brothers found, we need to talk about what they were supposed to find. Because the surprise only has meaning when you understand what was expected. Imagine our sun is not just a ball of light and heat. It is a machine that never stops producing. Every second, it continuously blows out a stream of electrically charged particles called the solar wind, flying outward in every direction at millions of kilometers per hour. That wind pushes into the surrounding space and creates an enormous bubble that encloses the sun and everything orbiting it. That bubble contains every planet, every moon, every spacecraft humans have ever launched, and every living creature that has ever existed. Inside that bubble is our home. The outer edge of that bubble is the point where the solar wind is finally stopped by the pressure of interstellar space pushing in from the other side. That edge is called the Heliopause. It is the true physical boundary of the solar system. But here is something very few people know. Before Voyager 1 touched that boundary in 2012, not a single scientist on Earth knew exactly where it was. The models only gave a very wide estimated range. The boundary of our own home had remained hidden throughout human history. And the physicists trying to draw the shape of that bubble arrived at a nearly unanimous answer. The bubble had to be symmetrical. If the solar wind blows evenly in every direction, then the bubble must be nearly spherical. Any point on the edge should be roughly the same distance from the sun. Ed Stone, who led the Voyager mission for half a century, later said a short sentence. When I look back, I realize how little we knew about the solar system before Voyager. The second expectation concerned the transition across the boundary. There would be no hard wall, only a thick and blurred mixing region, like where a slow river meets the sea, two environments blending across tens of billions of kilometers. And the third expectation, the most important of all, the magnetic field had to change direction. Inside the bubble, the magnetic field belongs to the sun. Outside, it belongs to the galaxy. When a machine crossed the boundary, the magnetometer on it had to record a sudden change. This was the absolute signature, and the story of that difference began on the 25th of August, 2012. That was a day no one at NASA marked right away, because at the time, no one was sure what had happened. The 25th of August, 2012, no press release, no announcement, only streams of data flowing back from tens of billions of kilometers away, and for many months afterward, no one could agree on what they meant. And there was a very ironic problem here. The plasma instrument on Voyager 1, the instrument that was supposed to be the most important tool for answering whether the machine had left the solar system, had failed in 1980. It failed while flying past Saturn, 32 years before the day Voyager 1 reached the boundary. Not only the plasma. During the long years of waiting in the outer region, the engineers had successively turned off a whole series of instruments to conserve power. By 2012, the machine had only about half the instruments it had at launch. Without a plasma instrument, the scientists had to rely on another device called the plasma wave detector. It could only measure density when a strong enough event on the sun created a wave that reached where Voyager was. That meant waiting. In the spring of 2013, a strong enough wave arrived. The instrument recorded density jumping suddenly 80 times higher than in the outer heliosheath. But even with that number, the debate did not stop. One group of scientists said the boundary had been crossed. Another group argued against it. By September 2013, after more than a year of analysis, the official announcement was finally made. The recorded date was the 25th of August 2012 at a distance of 121.6 astronomical units from the sun. But when the detailed scientific papers were published, an uncomfortable picture emerged. The boundary Voyager 1 had just crossed did not look like anything the models had predicted. The first surprise was the thickness. The transition region was not a thin line. It was a turbulent zone that took years to cross, not a border. A region of magnetic field bubbling like a pot of boiling water, full of small magnetic bubbles formed by the solar wind swirling and colliding with the pressure from outside. Crossing that region was not like stepping through a doorway. The second surprise was even harder to accept. Before Voyager 1 reached the true boundary, the machine had flown through two tubes of material from outside, two regions of interstellar matter that had slipped backward into our bubble, like two fingers poking back through the fence. No model had predicted that. The boundary was supposed to be sealed. It had been breached. And the third surprise, perhaps the one that shook the scientific community most deeply, when Voyager 1 finally crossed the true boundary, the magnetic field did not change direction. This was the signature every model said had to occur. It was the absolute proof. But the magnetic field on the other side was nearly parallel to the field inside. Same direction, same tilt, no change. No one at the time knew how to explain it. The question was left open. And all of these discoveries came from only a single observation point, with only half the instruments still working. The scientists all knew the same thing. A second witness was needed. Voyager 2 needed to reach the boundary carrying a still living plasma instrument on the other half of the bubble. But Voyager 2 was still far away, very far, 6 years. That was how long the Voyager scientists had to wait, from August 2012 to November 2018. 6 years without an answer to the biggest question this mission had ever asked. What is the true boundary of the solar system? Were the things Voyager 1 measured a general rule, or only a random point in a larger structure? 6 years in which only Voyager 2, slowly flying south, could provide the answer. And during those 6 years, something very human was happening at the Jet Propulsion Laboratory in Pasadena. The lead scientists of the mission were growing old. Ed Stone, who had taken the position of Voyager project scientist in 1972, 5 years before the machines were launched, when he was 36 years old, was still leading the team. By 2012, he was 76. No one else in NASA history had held the project scientist position for a single mission for so long. Stomatios Krimigis, principal investigator of the particle instrument at Johns Hopkins University, was also waiting. No one on his team was younger than 50. The doctoral students he had trained in the 70s were now grandfathers. An entire generation of physicists had been born, learned their craft, and were now preparing to retire, all while waiting for a machine to pass through an empty region of space. This is something science videos never tell you. Scientific missions do not always have the rhythm of continuous discovery. There are missions you have to build over an entire career, pouring all your intellect and time into a single question, then finally have to sit there and wait. There are missions some scientists will not live to see the answer. During those 6 years of waiting, the story of Voyager 2 had begun much earlier than most people knew. In 2007, the machine had crossed a first boundary called the termination shock, the region where the solar wind suddenly slows down. That was the first wall, only the first sign that the machine was drawing near. 11 years later, Voyager 2 was still slowly crossing the outer heliosheath, advancing toward the second wall. By 2017, about 400 days before crossing, the speed of the plasma flow around Voyager 2 began to drop. This was the first sign. The science team knew. Ed Stone knew. The 6-year wait was about to end. But one thing made this period more tense than anything else. The Sun was in a completely different phase of its 11-year activity cycle. When Voyager 1 crossed the Heliopause in 2012, the Sun was near maximum activity, the bubble at its largest. When Voyager 2 was expected to cross in late 2018, the Sun was near minimum, the bubble should have been at its smallest. NASA used a very easy comparison. The Sun breathes like a lung. Strong activity inflates the bubble, weak activity shrinks it. The models predicted very clearly. Voyager 2 should meet the Heliopause at a distance closer to the Sun than Voyager 1 by about 10 to 15%. And when that day finally arrived in November 2018, what Voyager 2 sent back did not look like anything the scientists had prepared for. The first letter arrived at night California time, the 5th of November 2018. The plasma instrument on Voyager 2, the instrument that Voyager 1 had lost 38 years earlier, suddenly recorded what the engineers at the Jet Propulsion Laboratory had waited an entire generation to see. The plasma flow around the machine abruptly dropped to zero. Not a gradual decrease, not a blurred fading, sharp as a knife edge. Within a few short hours, the environment around Voyager 2 shifted from inside the solar system to outside the solar system, as if someone had just pulled a curtain. And this was the first difference from Voyager 1. The transition region that Voyager 1 had to fly through for years of ugly turbulence was for Voyager 2 only a thin line. Sharp, clear, no mixing, no gentle transition. This was exactly what the plasma instrument on Voyager 2 captured. This was the answer its older brother could not measure directly 6 years earlier. On the southern half of the solar system, the boundary is not thick. It is so thin that in only a few hours, the machine went from the solar system into interstellar space. The second difference was the absence. Voyager 1, before crossing the true boundary, had flown through 2 tubes of interstellar material that had poked backward into our bubble like 2 fingers through a fence. Voyager 2 saw nothing at all. No fingers from outside, no penetration, no sign of the boundary being breached. In the south, the border of the solar system appeared intact in a way that in the north, it was not at all. The third difference was an entirely new discovery, something no model had ever predicted. Immediately inside the Heliopause, Voyager 2 measured a region the scientists named the magnetic barrier. That is a zone where the Sun's magnetic field is compressed far denser than theory allowed, forming a true energy barrier pressed tightly against the edge. This barrier itself affects how galactic cosmic rays penetrate into our bubble. No model had a place for it. It did not exist in theory, it existed only in the data. And when Voyager 2 crossed the Heliopause itself, the plasma density rose about 20 times, not 80 times as with Voyager 1. The compressed boundary in the south differed from the turbulent boundary in the north in every measurable way. The fourth difference, and perhaps the one that shook the scientific community most, was not a difference, but a similarity. The magnetic field outside the Heliopause, just as in the case of Voyager 1 6 years earlier, once again did not change direction. The same phenomenon that had caused confusion in 2012 now repeated on a completely different half of the solar system. 6 years earlier, the scientists could have said it was a coincidence at a single observation point. It might have been random, it might have been due to location. Now they had 2 observation points tens of billions of kilometers apart, in opposite hemispheres, and both saw the same thing. It could no longer be random. The magnetic field of the Sun and the magnetic field of the galaxy are not 2 separate systems as every theory had taught. They are connected, at a fundamental level no one had predicted. And the final point, the one that made Krimigas use exactly 2 words in the press conference afterward, was the distance. When Voyager 2 crossed the Heliopause, its distance from the Sun was 119 astronomical units. The distance of Voyager 1 when it crossed in 2012 was 121.6 astronomical units. The difference was not even 3%. But the Sun at those times was in 2 opposite phases of its activity cycle. The bubble should have expanded and contracted. Voyager 2 should have met the Heliopause much closer to the Sun than Voyager 1, but it did not. The boundary in the south lay at almost exactly the same distance as the boundary in the north. The bubble was not breathing like a lung at all. Krimigus, when asked, used only 2 words. Very strange. Later, Anton Petrov summarized that coincidence in a much simpler way. The sun is breathing, but the 2 brothers arrived at the boundary exactly when the sun's lung was not breathing in that part. And all 5 of these differences, when put together, began to point in only one direction. The bubble that protects us is not symmetrical. It does not inflate and contract evenly as the models taught. It has 2 different faces, under different pressures, with different structures. And no model had a place for it. On the 10th of December 2018, at the annual meeting of the American Geophysical Union in Washington, NASA officially announced Voyager 2's crossing of the boundary. Ed Stone, 82 years old at the time, stood in front of the cameras. 1 year later, 5 scientific papers were published simultaneously in the journal Nature Astronomy, and a final picture began to take shape. This is what those 5 Nature Astronomy papers and the studies that followed over many years afterward gradually led the scientists to. Not a complete answer, but enough to understand why the 2 brothers had sent back 2 letters so different. The first answer changed every diagram in the textbooks. The shape of the bubble that protects us is not a sphere, it has a far more distorted form. One side nearly round, the other stretched into a tail, like a croissant pressed hard from many directions. Even the spherical part is not evenly round. The surface is continuously deformed by magnetic waves that can stretch as far as 10 times the distance from Earth to the Sun. The cause is the magnetic field of the Milky Way in the local region. It presses unevenly on the bubble, compressing one side, allowing the other to expand. And this is what finally gave meaning to the 2 letters from the 2 brothers. Voyager 1 crossed in the north. That is where the bubble is less compressed, the boundary weaker. That is why the transition region was thick and turbulent, why streams of material from outside could slip in and penetrate, why the boundary appeared blurred. Voyager 2 crossed in the south. That is where the bubble is more strongly compressed, the boundary firmer. That is why the boundary was sharp, thin, and intact. That is why the magnetic barrier existed in the south. Voyager 1 was not wrong. Voyager 2 was not wrong. Both were right. But they were describing 2 different regions of the same asymmetric structure. The second answer resolved the mystery of the distance. The sun's 11-year cycle does truly affect the shape of the bubble, but that effect is mainly in the tail, not at the front. At the front, where both brothers crossed, the cycle barely changes the distance. The bubble does not breathe like a lung at the front. It breathes at the rear. The 2 brothers arrived at the boundary exactly when the sun's lung was not breathing in that part. The third answer changed physics. The magnetic field of the sun and the magnetic field of the galaxy truly are connected, not like a bridge, but like 2 nets interwoven across the boundary. The magnetic field lines break and reconnect in a new way, exchanging energy. Anton Petrov summarized this in one sentence. The north-south magnetic axis of the solar system and the north-south magnetic axis of the surrounding galaxy are nearly parallel. That is not a coincidence. Our bubble is not an isolated cell. It is an open cell, continuously exchanging energy with the surrounding environment. But knowing why does not mean knowing everything. We still do not know the exact shape of the bubble at the tail. We still do not know the exact degree of distortion. The instruments on the 2 Voyagers measured that the bubble protects us from about 70% of galactic cosmic rays, those high-energy particles that can break DNA and harm life on the surface. But if the shape is asymmetric, that 70% level is not uniform in every direction. There are directions with 90% protection. There are directions with only 50. And Earth orbits the Sun, facing all those directions at different times of the year. But there is something very human in this entire story that I want to pause a moment to tell you. On the 9th of June 2024, Ed Stone passed away at his home in California. He was 88 years old. He had led the Voyager mission for 50 years. From 1972, 5 years before the 2 machines were launched, until he officially retired in 2022. If you count from the day he took the project scientist position to the day he left it, that is exactly half a century. No one else in NASA history has devoted so much time to a single mission. No one else has ever been tied to a machine for so long. And this is the most remarkable thing. He lived long enough to see Voyager 1 cross the Heliopause in 2012. He lived long enough to see Voyager 2 do the same 6 years later. He lived long enough to read the 5 Nature Astronomy papers when they were published simultaneously at the end of 2019. He lived long enough to hear the answer to the question he had spent half a century of his life seeking: what shape the bubble has, why the 2 brothers sent back 2 different letters, and why both were right. There is a sentence Ed Stone said when interviewed near the end of his life, a sentence so short you might skip it the first time you read it. When I look back, I realize how little we knew about the solar system before Voyager. We discovered things we did not even know were there, again and again. That is perhaps the shortest sentence ever written to summarize half a century of a scientist's life. But he did not live long enough to hear the 2 brother machines finally fall silent in their turn. That will happen at some point in the 30s. Both brothers, born in the same summer 49 years earlier, will die at two different positions. One will continue flying north forever, one will continue flying south. Both will carry the same golden record. That is a golden disc containing 90 minutes of music, human laughter, the sound of ocean waves, 55 languages of greeting, and two messages from President Jimmy Carter and United Nations Secretary General Kurt Waldheim, two names your generation may never have heard. That disc is flying toward two opposite sides of the galaxy, and each machine is still trying to speak to us across a distance that light takes a day to cross, with only a transmitter of 22.4 watts. A small refrigerator light bulb. The official Voyager social media account, written as if the spacecraft itself were speaking, posted a line on the day Ed Stone died. How do we say goodbye to the man who helped make our destiny possible? Thank you for opening the door to our cosmic journey. You will always be remembered as your legacy continues to live beyond the Heliosphere. There are not many farewell sentences in history written by an inanimate object. If there are, I think this is one of the most beautiful. And now here's what no scientist at the Jet Propulsion Laboratory wants to say out loud, but everyone knows. After the two Voyagers fall silent, there is no other machine on the way to the boundary of the solar system. No mission is funded, no mission is seriously planned, no design is being built. No science team is waiting for a launch date. Only emptiness, and a different list of priorities taking the place. The next machine, if designed and funded and launched today, would take at least 25 years to reach the Heliopause, more likely 30 years. In that time, the question of the shape of our bubble will have no new data. The map the two brothers began to draw, the asymmetric, imperfect map based on only two observation points and two hemispheres, will remain the only map humanity has. And the span between the time the two Voyagers fall silent and the time the next machine reaches the boundary will be the longest period in the history of modern science in which humanity has moved backward in a specific field of knowledge. It has never happened since the scientific revolution began, but even after the final signal stops, the two machines will continue moving. Voyager 1, in about 40,000 years, will pass near a star named AC plus 793888 in the constellation Ursa Minor at a distance of 1.7 light-years. Voyager 2 will pass a different star named Ross 248 in the constellation Andromeda, also at a distance of 1.7 light-years, also in about 40,000 years. When the two brothers pass another star system, the children of your children, generations too many to count, will have long been born and died, not because we do not want to know, not because we cannot build another machine, but because we have not decided this question is important enough to spend another 30 years. The window will close until the children of today's children are old enough to retire. This is what I want you to take away from this story. We are living in a very special moment. This is the only moment in human history when we have two machines simultaneously operating in interstellar space. We have two observation points. We have two letters being sent back. We have two living witnesses to a question our ancestors could not imagine anyone would ever be able to answer. And that moment is ending, day by day. 4 watts of power lost from the radioisotope thermoelectric generator, instrument after instrument turned off to save electricity. The ability to receive more data about the place where you and I and everyone you have ever known are drifting through the galaxy is shrinking, bit by bit of data slower. Right now, only 160 bits per second, slower than a dial-up modem from the 90s. Ed Stone spent 50 years of his life waiting for the answer. He lived long enough to hear it before he died. Perhaps that is the greatest gift a scientist can receive. But he left before the two brother machines finally fell silent in their turn. Perhaps that too is a kind of mercy, not having to wait to hear that moment. We must wait. We are the generation that will hear the final signals. If you came to this channel because of stories with weight like this, subscribe right now and turn on notifications. Leave a comment with what in this story made you think the most. Share it with someone you know who needs to hear it. Because the two brothers are sending their final letters, and someone needs to read them before they are forgotten in the silence.